Okay, number 2 is also a multiple selection. Let the function p represent the population p of t in thousands of a particular colony of bugs t days after first being counted. Select all of the statements that are true about this situation. So what I'm going to do is I'm going to treat this as 4 different true and false questions, and the ones that are true are the answers. So let's start with A. Okay, so our equation, remember, is 15 times 1.05 to the power of t. And notice in our description it says, let the function p of t represent the population p of t in thousands of a particular colony of bugs t days after first being counted. So t, in this case, is the number of days based on our description. Because t is the number of days, then that means this right here, 1.05, is my growth factor per day. So growth factor per day is 1.05. So A is a true statement. A is a true statement. Okay. Let's see. B I'm going to do up here. All right. 1 week after the colony was first counted, there were 15,750 bugs. So let's go to our equation here. So 15 times 1.05 to the power of t. Remember again, t means days. So 1 week, 1 week is the same as 7 days, which means I need to plug in 7 for, not for x, but for t. So I need to figure out what 15 times 1.05 to the power of 7 is. So to do that, I'm just going to go on to Desmos. So on Desmos, 15 times 1.05 to the power of 7. Okay. And so that doesn't mean 21.1 bacteria. That means 21.1 thousand bacteria. So our answer here is 21.1 thousand. Okay. 21.1 thousand, last time I checked, is not equal to 15,750. So B is a false statement. C. There are 1,500 bugs when the colony was first counted. Okay, so again, going back to our equation, 15 times 1.05 to the power of t. What is our initial value? Our initial value is 15. Now, that doesn't mean there are 15 bugs. That means there are 15,000 bugs. So my initial value in this case, our initial value is 15,000. Okay, 15,000 is not equal to 1,500. So C is also a false statement. Okay, now let's do D. And D, I'm going to run out of room, but I'm going to do my best. Do that here. So 15 times 1.05 to the power of t. T, again, is days. Okay. So 1 week, let's see, D. The growth factor per hour is 1.05 to the power of 1 over 24. So let's go ahead and check that. So our growth factor per day is 1.05. Now we want to find our growth factor per hour. So just like we've talked about before, remember T equals 1 means 1 day, which is 24 hours. T, that's what happened here. T equals 2 means 48 hours, so on and so forth. So on and so forth. So to convert from hours to days, I basically have to divide by 24. Just like in number one. In number one, I was dividing by 2. In this one, I have to divide by 24. So my equation is going to be 15 times 1.05. And now I'm going to use h for hours. It's going to be to the power of h over 24. Right? To figure out my exponent, if I take the number of hours and divide it by 24, that will convert it to days. So h in this case is hours. And then to figure out the growth factor, I'm going to play that algebra game again. So I'm going to take the 1.05, I'm going to take the h over 24, and I'm going to convert that to 1/24 times h, right? Because remember, 1/24, 1 over 24 times h is equal to h over 24. Okay, we've done numerous examples like that. So with that in mind, that means my growth factor per hour is what's in the parentheses. So my growth factor per hour is equal to 1.05 to the power of 1 over 24, which is what D says. So this is a true statement. So the answer to number 2 is A and D. A and D are the only true statements.